Researchers at the University of California in Berkeley are printing electronic skin from nanowires. These flexible, low-power pressure sensors could bring a sense of touch to prosthetic limbs or help robots grip delicate objects. They're based on the largest nanowire transistor arrays ever made. The advantage of using these nanowires is that they combine the high performance of rigid silicon chips with the flexibility of plastic. Ali Javi, who was one of our top 35 young innovators of 2009, has developed a simple way to paint these materials over large areas to make many kinds of high-efficiency, low-power electronics, including the electronic skin, as well as solar cells and light sensors.
One of the challenges in using nanowires or any nanostructured materials is to be able to assemble them on large scales, especially be able to assemble them very uniformly in ordered fashion over large areas, and that has been a big challenge for the past 2 decades. And the approach that we have in assembling our nanowire materials is using contact printing, which is effectively basically painting wires down on any substrate, whether it's glass, plastic, paper, and we assemble them, we print them as parallel arrays by the contact printing force, and in doing so we end up with a very large area, fairly large area and uniform arrays of these semiconductor nanowire arrays. Once we have the nanowire arrays assembled on the substrate, we can build transistors, we can build sensors and diodes based on these nanowire arrays by using conventional fabrication processes such as lithography and etching.
The first step is to grow silicon germanium nanowires on the printing roller. Graduate student Toshitake Takahashi places the roller, which is simply a glass test tube, inside a chemical vapor deposition chamber. The roller has been coated with gold nanoparticles to seed the growth of the nanowires. Once the chamber is sealed, he will raise the temperature and flow in gases containing the two materials. Nanowires sprout up on the surface of the roller. The roller is now matte black because it's covered with tiny nanowires. It's fitted to the printer, a small steel table that supports the roller and a flexible sheet of plastic. As Takahashi moves the roller over the plastic, the nanowires stick to the surface and break off. The rolling motion pulls the nanowires into alignment, which is important for making a good transistor array. When the nanowires are aligned, electrons can move through them more rapidly, which is crucial for making a fast, low-power transistor material. Once the plastic is covered with nanowires, Javi's team uses conventional methods to make it into a transistor array. In the clean room, the researchers use lithography to add gates and electrical contacts to the nanowire array. To make the transistor array into a pressure sensor, it's laminated with a pressure-sensitive rubber. The rubber's conductivity changes when it's pressed. This change is measured by the transistors.
Right now we are limited by the size and the capabilities of the tools that we have in our lab. Most of the tools that we are using for depositing and printing nanowires are home-built tools. You cannot go and buy them. Moving forward in the future, we should be able to, we need to be able to grow these nanowire materials in large scales and be able to print them in large scales. So developing commercial tools that can do this over large areas would be very important to scale up this process.